Hello everyone and welcome back to exercise number 57 of SolidWorks Basic Tutorial Series. In this video, we're going to be designing a square mounting flange. As always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature, but also, if you look closely here, we have two threaded mounting holes for this top flange right here. So naturally, we're going to be using the hole wizard tool. Here we see the schematic drawing for exercise number 57. All dimensions are in millimeters. We have the isometric view. There are two isometric views showcasing the component at two different angles. Particularly, we have a isometric view showcasing the physical features of the component at the bottom, all right? Because here we see that we have protrusion. We also have the top view, the section view, and the section view is taken along this cutting plane, AA. And we have a detail view, which showcases the internal features for the hole here, the threaded hole. So it's a M20 by 2 type hole, right? And we have two of them on either ends of the top flange. All right, so in modeling this part within SolidWorks, obviously we're going to be following a feature-driven approach. So the idea is that we look at the physical features and then we determine the 3D processes or the 3D features that we're going to be using within SolidWorks. The first physical feature that we see standing out, of course, we look at the top view, is the square flange, all right? Right here, which is the largest flange within the component. So naturally, in creating this part, we're going to sketch out a rectangle or a square using the center rectangle tool, and then use the extrude boss base to create the thickness. And then we have this circular protrusion here, sort of like a boss, on the bottom of the component. So we're going to have to select the bottom face and then draw a circle, then use the extrude boss base tool. After that, we're going to create the 4 mounting holes. Of course, after we've defined the fillets or 4 corners of these the square base flange. And then we're going to create the last physical feature, which is the flange here at the top. And the idea is for us to sketch out the 2D profile clearly shown on the top view, all right? And then use the extrude boss base tool to create a thickness. In this case, the thickness is 31 millimeters. All right, and then add the holes. We have the counterbore feature for the hole right here in the middle. So again, we can use the hole wizard tool, or more naturally, we could create or use the extrude cut tool twice. First with a larger hole, and then for a second, okay? And that's what we're going to be using, the standard extrude cut tool, because it's intuitive and it's easy to use for beginners. Finally, we're going to be creating the 2 mounting holes. In this case, these are threaded mounting holes. If we look closely here, we have a cosmetic thread, not particularly shown clearly within the drawing, but again, represented by these dashed lines. And for that, we're going to have to use the hole wizard tool, which is a very easy process. The most important thing is for us to define the type of threaded hole or the drill thread. And here we can see that it's M20 by 2, and the depth, or the thread depth, is 26 millimeters, all right? And of course, finally, after modeling the part, we need to determine the mass of the part in grams. And here we see that we need to use a material of ASTM 36 steel, all right? And unless otherwise, all fillets have a radius of 5 millimeters. So unless we have a fillet here that's not defined, and hopefully I think all fillets are defined, by default, we're going to assume that it's 5 millimeters, all right? Okay, so with that aside, let's get started with exercise number 57. Okay, so to start, we create a new SolidWorks part. We set the background to plain white. Again, this is a personal preference. You can use different kinds of backgrounds. For example, use this color, but I personally prefer plain white, for those of you who are wondering. And we copy exercise number 57 into SolidWorks. All right, so let's drag this upwards. Let's reduce the size. All right, so step 1 involves creating this square base flange. So naturally, we're going to select the top plane, sketch, activate the center rectangle tool right here, and from that origin, draw a square, or rectangle in this case. Select these 2 entities, and then set the relation as equal. So it's going to become a square, a perfect square. Now activate the Smart Dimension tool, and if we look closely at the top view, we see that for the base flange, the dimension should be 154 millimeters. And this symbol right here, the square symbol, means that for this rectangle, it's a square. So the dimensions on this side and this side are equal. So this needs to be 154 millimeters. Okay, now just press the S key, extrude boss base. And if you look at the section view, we can see here that for the square base flange, the thickness should be 25 millimeters. And then click OK. All right, so that creates the base flange. Of course, we have a fillet for the four corners of the square here, square profile. So what we could do is just press the S key, select fillets. And if you look at the top view, we see here that we have 4 fillets for the 4 corners of the square, and each fillet has a radius of 26 millimeters. So go ahead and enter a radius value of 26, and very simply just select the 4 corners. That's 1, 2, 3, and 4. All right, and then click. Okay, so now let's proceed to create the extrusion here at the bottom. If you look at the section view, we see that the circular profile needs to have a diameter of 112 millimeters, and the protrusion needs to be 6 millimeters thick. So just click on the bottom surface, sketch, activate the circle tool. From the origin, draw a circle, activate the Smart Dimension tool, and this needs to be 112. Press the S key, extrude boss base. Again, set the thickness to 6, enter. All right, so that creates the protrusion at the bottom. Now let's just create the 4 mounting holes for the square base flange. So just click on the top base, sketch, activate the circle tool, and just hover your cursor over one of the curved surfaces, and that will wake up the center point of the circle. And the center of the 4 mounting holes corresponds to this point right here. So that's 1. Again, that's 2. 3, and 4. All right. Click on these 4 circles, holding down the control key to select them all, and set the relation as equal. So they're now they all have equal diameter. Activate the Smart Dimension tool, and from the top view, we see that we have 4 holes, and each hole has a diameter of 20 millimeters, and the holes are through. So what through means is that the holes go all the way through to the other side, as you can see here. Okay, so this is 20. Press the S key, extrude cut. Right click on your mouse, and then click on through all both directions, and then click OK. All right, so that creates the 4 mounting holes. Now for the tricky part. It's not necessarily tricky, but there's a certain degree of sketching to it. Now we need to create this top flange right here, this physical feature here at the top. So the strategy here, guys, is for us to sketch out the 2D profile that we see here, and then use the extrude boss base tool. Okay, so let's go ahead and select this top face, sketch. And if you look closely here, we need to create this 2D profile. And the easiest way is for us to first proceed by sketching our rectangle, all right? Then creating 2 circles, that's 1 and 2, and then using the line tool to create 2 tangents. And the tangent line here connects all the way to the center point of this line here, okay? So let's go ahead and create the rectangle. From the origin, draw a rectangle. Activate the circle tool, and then just draw a circle right here at any point. That's one of the circles. Click on the center of the circle, hold down the control key, and click on the origin. Set the relation as vertical. All right. Activate the Smart Dimension tool. The circle here, the largest circle, should have a radius of 18 millimeters. So this should be 18 multiplied by 2, since we're defining the diameter. All right. Okay. And as for the distance, we see that the distance from one end of the circle to the other, from one point to the next, it's 92 millimeters. And there's a point of symmetry among the x-axis. So activate the Smart Dimension tool, and from distance from this point to the origin should be 92 divided by 2. All right. See how the circle here turned into black, meaning that it's fully defined. We define the diameter, we define the relation of the circle, we define the position of the circle in relation to the origin vertically and the distance as well. All right, so activate the Smart Dimension tool. We see that for the rectangle, it is 38 millimeters from one end to the next by 126. So this should be 126 by 38. All right. Okay, now we need to create this rectangular opening. So what we need to do is just select corner rectangle, and from this point, just draw a rectangle. All right. And we need to set the relation between the center of this rectangle, this edge here, and the origin as horizontal so that, it's perfectly symmetrical. Activate the Smart Dimension tool, and we can see very clearly here that from one end to the next, the inner edge for the rectangles, it's 62 millimeters. So since we have the origin dividing the component in half, so it should be from this edge to the origin should be 62 divided by 2. All right. As for the thickness of the edge here, it should be 18 millimeters. So activate the Smart Dimension tool. This should be 18. All right, so now we just need to copy this to the other side. Press the S key, click on Mirror, Entities to Mirror, click on these 3 lines, 1, 2, and 3, mirror about this vertical line. Click OK. Now activate the Line tool and just draw a tangent all the way to this point right here. That's 1 and 2. Just make sure that the line is tangent to the circle. Okay, so that's tangent and tangent. It may be tangent, but I'm a person who suffers from OCD. I have to make sure everything's perfect. Anyway, so now just very simply, we need to mirror entities again. Mirror these 3 entities. You have 1, 2, 3. So click on these entities, mirror about this horizontal line, and click OK. Now we have the basic profile for the sketch. Now it's just a trimming process. We need to activate the trim tool and delete any extra entities that we don't need. All right, leaving behind the basic 2D sketch for the profile. All right. Just to be sure not to delete any extra entities. Anyway, so don't worry about any of the blue lines here. The sketch is fully defined in the sense that, all necessary dimensions are defined, and we use the mirror tool, so everything's okay. Now, what we need to do is very simply just press the S key, extrude boss base, and we're going to extrude this. If we look closely here, the extrusion should have a thickness of 31 millimeters. So enter a thickness of 31, enter, and then click and press on enter again. All right. Now press the S key, fillet, and we look closely here, the isometric view. We have 4 edges that need to be filled out, and each of the 4 edges has a fill radius of 12 millimeters. So enter a radius of 12. Click on these 4 edges, 1, 2, 3, and 4. Click OK. Click on the surface, sketch, activate the circle tool again, and we need to create the openings here. And this circle, we have 4 holes, and each hole has a diameter of 10 millimeters. As to where should we place them, if not defined, naturally, you need to just hover over your cursor over the curved edge here and wake up the center point here and place the circle on the point. All right. Activate the Smart Dimension tool. This is 10 millimeters. Press the S key, extrude cut. Right click on your mouse. Again, it's already set to through both directions, and then click OK. Now we need to do this on the other side. So press the S key, mirror. Notice how I'm using the S key. It saves a lot of time, you guys. Okay, so keep it as a habit to always use it. And just go ahead and select the right plane. Click OK. All right. All right, so now let's create this counterbore hole. And if we look closely here, we see that we have a counterbore feature, which is 40 millimeters in diameter, with a cut depth of 42. And then we have, for the smaller hole, we have a diameter of 28 millimeters, and the hole goes all the way through the component. So 40, 42, 28. On this surface, sketch, circle tool from the origin, draw a circle, Smart Dimension, 40, S key, extrude cut, 42, or just for that right click, blind, enter a cut depth of 42 millimeters, enter, enter. All right, click on this surface, sketch, activate the circle tool. From the origin here, draw a circle. This needs to be 28. S key, extrude cut, right click, through all, okay. All right, so that creates the counterbore hole right in the middle of the component. Finally, we need to create the threaded mounting holes right here. It's actually a drill threaded hole, okay? So what we're going to do is we're going to go to Features, select Hole Wizard. All right, just click on that. Go ahead and select the straight tap option. All right. And selecting the ISO standard, since we're dealing with the International System of Units here. And again, if you're based in the United States, you can use the ANSI, but I'm going to be using the ISO unit, okay? So again, size is M20 by 2. The thread depth here, if you look at the schematic drawing, it's 26 millimeters. All right, so this is 26. All right, so now that's fully defined, just go to Position, click on the face that you want the hole to be, and now you need to define the position. Position will obviously be, right here. If we hover our cursor over the curved edge and just go over the point here and click here, that's one. And as for the other, just hover and then click on the point here, that's 2. And then click OK. And that creates the threaded holes, all right? And yeah, that's the modeling process. So again, we need to assign a material of ASTM 36 steel. So for now, just delete this image. You can color the component, but before that, this is just assign the material. Right click here, edit material. Select ASTM A36. Let me just find out where it is. There it is, okay. Apply, close. Now let's color this. Go to Appearance, just click on nice yellow color. Again, if you want to color out the internal faces here to represent the metallic surfaces, you can do that as well. If you don't want to waste time, you could just move on to the next step, which is finding the final answer. But I like to color things. All right, so Appearance again. Let's select Grayscale and select a nice light brown color, light gray color. Click OK. All right. So now for the moment of truth, go to the Evaluate tab, Mass Properties, and we have a final answer of 5,819.58 grams. 5,819.58 grams. So 5.8 kilograms, if you want to round things up. That is our final answer. Okay, so that concludes exercise number 57. I hope you all enjoyed this video. If you have any comments or questions, please leave them down in the comment section below. I'll see you all in exercise number 58. Until we meet again, bye-bye.